Okay, it is very simple ruler. But what is the good thing in a vernier caliper as compared to ruler is that when we measure anything with our regular ruler, we can measure like in integers only. Like for example, if I have to measure 17.5, okay, so 17.5 we have to measure like closely. If I see na like okay, let me take some example with which you will understand better. If I want to measure, let's say 17.6 or something, okay. So what we'll do in our ruler, we will just mark 1 point after that 5. Means everyone has seen the ruler. So let's say this is 17, this is 18. Between 17 and 18, there are 10 markings. This is 17.5. And we mark exactly over here at 6. Okay. But what happens since the pen or pencil, whatever we are using for the marking, they themselves are comparatively thicker. So we think that we have marked it correctly, but it do not come precise. It do not come properly. Okay. So to reduce that error, because ultimately it is all about we have to measure the length more precisely with more precision. So to reduce that error, to increase the precision and accuracy, we have introduced this device. Okay. So this is like a ruler only. The only difference is it has a capacity to measure up to 3 significant figures. Okay, what is 3 significant figures? So you can see that this 17.6 is a value written in 3 significant figures. Okay, now how do we measure it? So for that, there's a procedure. They have magnified this point over here. So I'll just zoom this magnified version and I'll show you that how we have to observe. This is a practical topic. Okay, so all of you just focus on this circular part, okay, and try to see that the one which is on in the background, there is one scale in the background. Okay, over here you can see this is a scale of the background. So that scale is called as main scale. Okay, as you can see here, it is a main scale, and the one which you see at the front with that screw and everything, that is called as vernier scale. So the vernier scale is used for measuring millimeters, or I can say the first decimal place. So from here, what I can conclude that this vernier scale is actually having 10 divisions. 10 divisions means from 0 to 1, you have divided it, means 1 centimeter, you have divided it further into 10 divisions. So I can say that each division is representing 1 millimeter. Okay, on the vernier scale. And the one which you can see on the main scale, that is representing centimeter, like our regular ruler. Okay, so till here, is it clear to all of you?
Yes, sir.
Yes,
Rohit?
sir.
Yeah, okay, just a minute. Let me just message in the group for Rohit. Okay, so on the main scale, if you will look at the reading, you can see that this 0 of the vernier scale is on the right of 3.5. Can you see that this point is 3.5? A point between 3 and 4 will be 3.5.
Yeah.
Okay,
Yes, sir.
this is how we have to observe. If this 0 is on the right, this 0 is of the vernier scale. Okay, so if it is on the right of that point, so we can definitely measure till here, and the main scale reading will be treated as 3.5. Main scale reading is 3.5. Now comes the vernier scale reading. Now for vernier scale reading, you have to look for these 10 lines and look at the 2 lines which are exactly aligned with each other. Which 2 lines? The one which is there in the white window plus the one which is there on this vernier scale. Okay, I'll just zoom this further and yeah, this is the maximum zoom I can do. Okay, So now try to find the two lines. I hope you can see the spikes which are there on the either side of these.
Yeah,
Okay,
sir, we can.
this side. So which two lines are exactly aligned?
Seven on the Vernier
Sir, can
scale,
you
sir.
repeat that?
I'm asking that which two lines are exactly aligned over here. So Akbar
This
is
is the
saying
seventh
7.
one.
Akbar is saying 7. Is there anyone who thinks any other?
Seven, sir.
Okay. Samuel, do you agree with 7?
Mm, yeah. Yeah, I guess.
Okay.
Wait, sir, 1 second.
This is exactly
Uh,
you have to do when it will be practicals in school. Okay, you should be able to
okay.
observe it. Okay, so how you have to observe, I hope that thing is clear to everyone, that we have to look for this 0 and just a point near to 0. So we just saw that 3.5 is a for sure reading on main scale. Okay, after that, the two lines which are getting aligned is exactly at the 7th point. So you guys are right in that also. So 7th point means I was saying that vernier caliper, each point is 1 millimeter. So I can say it will be 7 millimeter. 7 millimeter can also be written as point 7 millimeter, which can also be written as 0.7 centimeter. Okay, so if I want to write it down properly, okay. Yes, 7 millimeter can also be written as 0.7 centimeter. Okay, so this was how much? This was 3.5 centimeter and 0.7 centimeter. I think there is something wrong in this. Just a minute. Okay, there is one small correction which I have to make. This 3.5 centimeter is correct, okay, but we need to measure them in millimeter, okay. I once again repeat, this vernier caliper, vernier scale is showing us 10 measurements, but this 10 measurements are actually of 1 millimeter, okay. I repeat again, these are actually of 1 millimeter, so 1 millimeter is divided by 10, so each of the measurement will be of 0.1 mm. We got 7. So that 7 will exactly represent 0.7 millimeter. Okay. The only change which is there in the whole setup is that I initially told that this will be 1 centimeter divided by 10. It is 1 millimeter divided by 10.
So
Okay.
it's 1/10 of a millimeter.
Yes, it is 1/10 of a millimeter. So that's why it will be better and it will be more precise than our regular scale, because in our regular scale it is 1/10 of a centimeter. Okay, so I hope that this first difference is clear. This might be a question in few of your minds that why we have to use this if we can do the same thing in regular scale. So regular ruler can measure up to 1/10 of a centimeter. This can measure up to 1/10 of a millimeter, means more precise. So 3.5 centimeter means 35 millimeter, and 0.7 millimeter, if I just combine them together, my reading will be 35.7 millimeter. Okay, please have a look at it once again. If there is any doubt to anyone in understanding, okay, I'll just repeat few important points. The vernier scale is having 10 divisions. These are the 10 divisions of 1 millimeter. So I can say that each division in vernier scale is of 0.1 millimeter. So how you will count the measurement from the vernier scale? You have to see the aligned line. Whenever the two lines are aligned, that will be our actual marking. So that you will observe and you can calculate that. Okay. And after that, the main scale reading, how you have to see. So you have to just look at the 0 value, and just the value before 0 value will be your main scale reading. So in this diagram, it was 3.5 centimeter, which is converted into millimeter. That's why the answer will be 35.7 millimeter. Now, before moving on or before anything else, I just want you guys to read these 3 points. Okay, just read this para soon, and if there is anything you couldn't understand or doubt, we can discuss on that. They have mentioned the rules how to measure. The main scale reading is always taken with respect to the zero of vernier caliper. So that part I'm zooming it once again. So if you look at this diagram, the zero of vernier caliper is lying just after 3.5. This is 3.5. So the main scale reading from here, it is confirmed that it will be 3.5 centimeter or 3.5 into 10, 35 millimeter. Why it is better to write it down in millimeter? So that it can be adjusted properly with vernier caliper readings. Okay, so till here, everyone is clear that how I got 35 millimeter. Forget about that decimal thing. This thing should be clear first.
But I thought the main scale was in centimeters.
It is in centimeter, no? That's why I have written 3.5 centimeter. Look,
Oh yeah, okay.
1 centimeter is equal to 10 millimeter. So we have measured it in centimeter only, but then in the end we have to convert. Why we have to convert? Because
Okay, yeah.
the vernier scale is giving me the value in millimeter so that I can add properly. Okay, it is
Okay, sir.
3.5 only. So is it clear for all?
Yes, sir.
Now, how to measure the vernier scale? So for that, we have to look for these lines. Okay, so this is purely observation. We have to look for these lines and we have to look for the most aligned two spikes. Okay, that which two spikes are the most aligned ones. So by observation, we saw that it is coming at 7. So it is the 7th marking of vernier caliper. It is the 7th marking of vernier scale. So 7th marking of vernier scale means it will represent 0.7 millimeter. Okay, because on vernier scale, 1 millimeter is being divided into 10 different markings. So if it is 7th marking, it will be 0.7 millimeter. Now it is very easy to add them. 0.7 millimeter and 35 millimeter. So my answer will be 35.7 millimeter. So that is how we measure using vernier scale. Okay. Vernier scale has a power to measure up to 3 significant figures. These are all possible questions. Okay, 3 significant figures. Then what else it has? It can measure properly the millimeter values also. Like in a regular scale, we cannot measure millimeter values. Okay, we can measure only up to centimeters. So I'll just write it down here. It can measure up to 3 significant figures. Okay, and it is giving us more precise length value than a regular ruler. Okay, is it clear, Sammy? Is it clear now?
Yeah, a bit more clear.
Okay, we'll do one question. Possibly it will become more clear.
Yeah.
So I hope everyone else is also clear with it. Rohil, you can just observe it. Okay, even in the question also you can observe how it is being done. Possibly you will also understand. Okay, now just have a look at this question. We need to measure, we need to just write the measurement of this. Okay, so I'll just zoom it. You guys try to observe it properly. Okay, the grayish one which is there, that is the vernier scale. Okay, and okay, try first.
I got an answer, I think.
Okay, first, what is the reading of main scale? Can anyone tell me the reading of main scale?
0.4 centimeters or 14 millimeters.
Okay. Main scale from 1 to 2, this is 1.5. Okay. How do we get the reading of main scale? So we have to look for the 0. Now I'll zoom it further. Okay. And try to observe that this 0 is actually on right of that 1.5 marking. Can you see that?
Yes, sir.
It is not exactly aligned, or even it is not before that. It is after that 1.5 marking and it is on the right. This is all about observation. Oh, the dog also wants to study.
Oscar, go, Oscar.
Okay. So the main scale
My-
reading will be 1.5 centimeter. How many of you are okay with this? 1.5
It's clear,
centimeter.
sir.
Okay. Now
But if it
1.5.
was on 1.5, then it would be 1.4.
If it was on 1.5, then answer would have been 1.5 only.
Oh, wasn't it supposed to be 1 to the left of the 0?
So 1 to the left of. Okay, look. We need to see the nearest reading to the left of 0 marking. Okay. So if the nearest reading comes on the 0 marking, then think about it logically. That itself will become the reading.
But it's not to the left of 0 then.
Okay, you're not getting. Look. Over here also I'll try to show you that thing. Okay, here it is clearly visible that it is to the left. Okay. After that, when it is getting aligned with this vernier caliper marking, so it is getting aligned over here. Okay, that is what we have to see.
Yeah.
Understand this point. Okay, we have to see that when they are getting aligned. Are you clear with that point?
Yeah.
Now, if they get aligned at 0 itself, that is the best thing, na? Usually it will not happen in the question, but your question was what if it is at 0? So you have to understand this thing, that what are we observing? We are observing that when they are getting aligned. Just look at these spikes and we need to search for the best aligned line, the best aligned, the two spikes which are aligned. Okay, so it is happening over here. But in this case, let's say in this example, if the same thing happens over here only, then game over. We need not do anything else. Answer will be this only. Because why we have to see for the left? Because it is not aligned with the 0 scale. Then we see the nearest left main scale reading, and then we see that this vernier caliper is aligned at what point? Are you getting?
Okay.
I
I
still
get it a little
it
bit.
is not clear, but you just understand one thing, that we have to make sure that these lines and the lines which are above should be aligned. Okay. Since
Okay.
usually it do not get aligned, so they have made a rule that first you just write down the main scale reading. Okay, main scale reading means if you do not have vernier caliper, what you would have written. Okay, so that is 1.5. Now you will look for the alignment of two scales, that when they are getting aligned. So the point at which they get aligned will be your actual reading. So like in this example, at which point they are getting aligned?
1.5.
1.5, they're not getting aligned.
At 0.
No, 0 also they are not getting aligned. Let me zoom it more.
What?
You can see this 0 line is just on the right. Just try to look for a small tilt over there. It is not exactly aligned. Okay,
Oh, okay. So
this is the
0.1
maximum line.
millimeters.
It is getting aligned at this point. Okay, so what I am trying to say over here is that we have to look for the reading where there is maximum alignment, or where it is exactly aligned. Now, if it is exactly aligned at 0 point only, then the answer will be that only. Okay, that was your question, that what if it is at 0? then you cannot take 1.4. You have to take that only. Okay?
Yeah.
Because what we are doing,
Okay.
we are trying to compare two scales and we are trying to get the point where both of them get aligned with each other. That will be the actual reading. That is the main principle of measurement. Okay, that thing should be
Okay.
clear. It is not only about that to the left we have to see. Okay, usually in questions it is observed that they do not ask any such question where it is on the line. But just to create confusion, they can. If it is on the
Okay.
0 point, if actual reading of the main scale is on the 0 point, it will be the same answer. Okay, so for this question, what is the answer?
1.6.
Okay, now you have to understand that this is 0.1 millimeter and the main scale reading is 1.5 centimeter.
So 1.51.
1.51 centimeter.
15. Yeah.
Look, 1.51 centimeter is also correct and 15.1 millimeter is also correct. It all depends. Both of them are three significant figures only, so it doesn't matter. Okay, it all depends which unit they are asking. Okay,
Okay.
usually we write the answer in this unit, but both of them will be fine. Okay, so at least for this question, are you clear with how we have to observe?
Yeah. So we look at the 0 first. And
Yes,
if it's not aligned, then we look at the one nearest to the left.
yes,
But if it is aligned, then we look at the one it's on.
yeah,
And then we look at the division lines and we see which one aligned. And
yes,
then we add the data.
yes. And this addition should be done in millimeter, preferably. Okay, so you will get the correct answer properly. Okay,
Okay.
clear to everyone?
Yes, sir.
Now the next thing which we have to study is screw gauge. Screw gauge is also called as micrometer. Okay, screw gauge is a similar type of instrument which is used to measure the length only. Okay, now I'll just explain you the whole timeline that why we have to do vernier caliper and now why one more. Okay, right now like you have to do one more. So let us understand that timeline. When I talk about a regular ruler, the main scale of that is centimeter. Okay, in a regular ruler, 0 to 1 centimeter is divided into 10 units, each 1 millimeter. Okay, I'm just trying to write it down so that comparatively you guys will understand that what is the difference between all three of them. Regular ruler means the scale which we have been using from childhood. Now, at least if I talk about that scale, then it has become obsolete because vernier caliper is better when we talk about precision. Because please remember, the whole motive of discussion is that we are trying to find more precise value. Okay, not accurate. Accuracy is different. I hope everyone is clear with the meaning of accuracy and precision. Is there anyone having doubt in accuracy and precision?
No, sir.
Okay. Anyone else have doubt?
No, sir.
Assuming that all are clear with accuracy and precision. Okay. Still in upcoming questions,
But
I'll
sir,
yes.
I understand the difference, but why are we looking for precise readings instead of accurate to the true value?
Okay, look, accurate to the true value is because, like, for example, let's say there is any machine operator which you have hired. Okay. And the main role of that machine operator is that he or she has to take the readings and fill the log. It happens in many factories. Okay. Now, if that person is taking the reading, okay, and if that person himself or herself is doing some mistake in writing the reading, that is what we call it as accuracy. Okay. So that accuracy can
Okay.
still be improved if you train the person. Like, for example, right now you don't know how to take the reading from vernier caliper. So I can train you and then you will be fine with that. But what if your vernier caliper itself is faulty? Then what will happen? Are you getting this? Accuracy is
Then
like,
you're,
then it will not give you a precise answer.
but it won't give you an accurate answer either.
Okay, what I'm trying to explain over here is that accuracy can be improved by training the person or by replacing the machine itself. Let's say machine is faulty, you replace the machine. Okay. But precision can be improved only by improving the technology of the machine. For example, if your machine can measure up to 1 decimal place, then you cannot expect that it should measure more than that. Like, for example, if a value is 0.93, okay, and if it is 0.93 gram of gold, and you have a machine which can measure only up to 1 decimal place, then can you think that you are actually giving this much amount of gold for free to the customer?
Yeah.
Okay, I think this example will make you understand the difference between accuracy and precision. It is not that person is measuring it wrong. It is not that machine is also measuring it wrong. Okay,
It's
let's
just
say
the capability of the machine.
it is just the technology, or it is just the functionality of the machine which is not there. That's why we are not getting precise value. So over here, the
Oh,
finding
so
for
the
precision.
precision depends on the machine, but we can fix accuracy by how we use
Yes,
it.
yes, yes. If you do a mistake, then definitely you will take some faulty reading. Then it is not a problem of a machine. So that is inaccurate reading.
Mm.
Okay, you can even take inaccurate, precise reading. This is a very important point. Okay, everyone, please understand it carefully. When I say 10.35, 10.35 is a precise reading because it is up to 2 decimal place. But if the actual reading was 11.35, then your reading will not be treated as correct. It is inaccurate, though it is precise. So precision goes when we are going deeper into decimal places, like 3 decimal place, 4 decimal place. This is more precise. Okay, like for example, your calculator can give you only up to 8 or 10 decimal places. After that, it will not give you precise value. It may give you accurate value. Accurate means since it is of good quality, good company, it will give you accurate rounded off value, but not the precise value. Okay, and what is the main role of precise value? Then you can understand in the example of gold. That if you don't have that weighing machine, you are letting go this quantity of gold in each transaction for each customer. Okay, and this is actually like, you just imagine that there will be thousands of customer in a month, so how much loss your company has to bear, and no one will understand why this is loss. Okay, so these are like disguised things. Okay, coming back to my point once again, so the regular ruler can measure properly up to centimeters only. Okay, like because this division is 10 units, but 10 units are each 1 millimeter. When I moved on to vernier calipers after a ruler, so vernier caliper scale was also having 0 to 1 marking only, if you remember. Okay, and this 0 to 1 marking was divided into, in fact, it was 0 to 10, and each marking was treated as 1/10 of a millimeter. Okay, so I can say that this is also divided into 10 units. Okay, but 10 units, how they are created? They are created by doing 1/10 millimeter. So it is clear now that your regular scale can measure 1 millimeter, but Vernier scale can even measure 0.1 millimeter. So it has become more precise. Both of them will be accurate because you are not measuring it wrong. It is not that till now with using your ruler you are measuring it wrong. With the best of your understanding, you were measuring it correct, but your ruler was not up to the mark. So vernier caliper is more precise in that context. Is it clear to everyone?
Yes.
Yes, sir.
Mr. Rohit,
Yes.
so 0 to 10 is in the units of millimeters, right?
0 to 10 are the markings which are actually representing 0.1 millimeter each. So if I am at the fifth marking, my answer will be 0.5 millimeter. Okay. So
So
this is
10
divided.
so okay.
This is divided into 10 units, and each is, okay, you can see here I have written each is 1/10 millimeter. So it is 0.1 millimeter. So literally it is 10 times more precise than the ruler.
Okay, sir, got it.
Okay. Now coming to the micrometer, or it is often referred to as screw gauge. In micrometer, the whole procedure is exactly same. The only new thing is, which is the best thing of a micrometer, that instead of that scale, they have introduced a shaft. Okay, I'll just show you in the diagram. So just try to observe this shaft. Okay, I'll explain you that what is this. So this is the shaft. This is like a rotating shaft which you can rotate and you can see the alignment. Once again, the real fight will be you have to see the alignment only. Okay, I'll explain you how and when and everything we'll see. So the shaft of that screw meter is divided into 50 divisions. I repeat, this is divided into 50 divisions. Okay, it is divided into 50 divisions, or I can say 50 units. Okay, so 50 units means one, and each of the unit will be treated as 0.01 millimeter value. Okay, 50 divisions and each will be 0.01 millimeter. Now how 0.01 millimeter? That we can see here. Just have a look at the diagram, this magnified version of the diagram, and you can see that this is the shaft. Okay, you can even see the markings on the shaft. Okay, so the one which you can see, this horizontal, this is the main scale, and that shaft is called as screw gauge or micrometer. Okay, there are total 50 divisions in that, and you need to just see that where it is getting aligned with respect to this. Like they will show you the still images and you have to just count the values. Like over here, if you see that this is getting aligned at 17th value. This is getting aligned at 17th value. Okay, 17th value means I told you that each of the division is representing 0.01 mm. Okay, so if it is 17th value, then I can write it down as 0.17 mm. I'll just multiply that by 17. So is this thing clear to everyone?
Yes, sir.
That up to 2 decimal places, I am getting a precise value. Okay, what about the main scale reading? So if you see the main scale reading just to the left, okay, just to the left. So this is 0, this is 1, this is 2, and this value is 2.5. So the point which you have to understand is that this gap, okay, can I make it more bigger? Yeah. This gap, okay, just look at the gap which I have marked with pink. Okay, now what happens when you will move the shaft, when you rotate the shaft, it will move that much distance which will be equivalent to this. And how much it has actually moved in distance, that will be same as the marking at which it is getting aligned. Okay, now this you don't have to do it right now. For this is a still image and you have to just measure it. So how do we measure it? Once again, I repeat the process. This is the main scale reading, which is 2.5 centimeter. Later on, I'll write it down as 25 millimeter. Okay. After that, this gap, which is actually measured with respect to the markings on that screw gauge. And how do we see that? So we have to see that this horizontal line is getting aligned at what point? So if you read the markings, it is 15, 16, and 17. So it is getting aligned at 17th marking. That is why, and each marking is 0.01 mm. That is why it will be 0.17 mm. So when we have to write the actual value, the actual measurement, it will be how much? 25 millimeter plus 0.17. So the answer will be 25.17. Okay, there is one more difference between vernier caliper and screw gauge. Let me write here only, because then the reading will be more better. In vernier caliper, main scale is a centimeter unit. Okay, means when you will look at the reading on the main scale, it will be in centimeter. While in screw gauge, the main scale which we were looking at over there will give the reading in millimeter. Okay, because we are going more precise, we are going more smaller in the value in the measurement. So this main scale will give me the answer in millimeter. Over here, the main scale will give me in centimeter. Okay, in vernier calipers, that vernier scale was divided into 10 divisions, and each division was 1/10, that is 0.1 mm. In micrometer, it is divided into 50 divisions and each division is 0.01. It is often referred to as that it is divided into 100 divisions and 1 millimeter is divided by 100. That is how they got 0.01. Okay, but this is comparatively unacceptable because over there are only 50 markings. So they say that when it takes 2 rounds, for 2 rounds of that shaft, it will cover 1 mm. Okay, I repeat again. I told you over here also in this diagram that this gap between the main scale, this gap between the main scale and this gap is nothing but the value which we are getting by rotating the shaft. Okay, so if you will rotate the shaft by 2 rotations, by 2 divisions, not divisions, by 2 rotations, then it will be total 100 divisions and then it will cover 1 millimeter. So with that logic, I can say that 1 millimeter in a screw gauge is actually divided into 100 divisions. Okay, but one shaft will have only 50 units. You will see in real also, so you will get only 50 markings on that. So you have to rotate it twice to get 1 millimeter. Okay, this reading what we can get over here, it is in millimeter. So now if I come to the actual calculation, it will be 2.5 millimeter plus 0.17 millimeter. So that will give me 2.67 millimeter. Okay, now it is open for questions. It's a bit difficult when we do it for the first time, but these are quite easy topics. So the main scale of screw gauge or micrometer will always give me millimeter values, while for vernier caliper it was giving me centimeter values. Okay, so this is a big difference which is there between both. Okay, now we need to just write the value for this. Okay, so how will I write? So I have to first see that which is the nearest reading before this shaft. So what is the main scale reading?
3 millimeters.
Correct, very good. So main scale reading is 3 millimeters. And then what is the reading on the shaft?
0.02.
0.22.
Correct, very good. So you should first be able to understand that this is 22. Okay, you should be able to count that. And then you should know the background story that each marking is 0.01. Okay, multiplication is very easy after that. So it will be representing 0.22 millimeter. Yeah, everyone was correct. Akbar, I hope this is clear to you as well.
Yeah, sir.
So 3.22 millimeter can be measured like this. Okay, so this was all about screw gauge and vernier calipers. Both of them are practical oriented topics. If a question will come in exam, the question will be like this only. They will give you certain pictures and based on that, they will ask you the reading. Okay, so at least from the exams point of view, you should be able to read these images properly. Okay, I'll see if I get more questions similar to this. I'll attach them in the class notes so you guys can do as a practice. Plus, I'll try to find some good animation videos on vernier caliper and screw gauge. I'll send it that also. Okay, so just watch those videos. You'll understand each and everything about the instrument properly, that how it works, how we have to measure it. Okay, so we can end today's lecture over here only. There were few questions which were good in Samuel's test. Okay, so I wanted to discuss that, but